Time for another draftphysics.com video presentation. Should be recording and such.
It has no choice. Nature can deal with kinetic energy one way or another, but it cannot finagle momentum. So it must give.
Alright, anyway, so, YouTube video, I guess. So we'll do a semi-quick review of the videos on the website, and I'll get to some more observations regarding the Franklin Who announcement and evidence, quote unquote, and the whole brozo thing, and the fact that there really isn't anybody on the subjects. I mean, they just keep evading the subjects. The subjects are these individual statements about how something works. I mean, does a spring collect kinetic energy, or does it collect momentum? It's a real question. I think the answer is obvious, but whatever. If you're going to make an argument, then you should make an argument explaining how, and show evidence of how. But anyway, so we'll get to some of that. I'm going to get to some arguments about the whole idea of motion and force penetration. There's so many interesting subjects. But anyway, we'll start with, I did do a video, the CNPS, which ironically or strangely, none of the members of that organization watch any of Franklin's videos or comment on them, which is sort of interesting, that they have no input, nothing. So, whatever, just strange. The Dehelsters, the whatever, all of those people. So anyway, they did another one of their videos on the Faraday paradox. The Harry Rinker guy just went over the same points over and over and over, and they really didn't get to anything. So this, it's very difficult to do physics when they can't agree on anything and they can't state anything, and you can't even argue about what it means if you say, okay, this is what it does, and now let's try to figure out why it does that. None of that's involved. So anyway, frustrating. Alright, then I did a video response to this Unsucker, Alexander Unsucker's cheesy, tacky, crappy, shitty, I mean, it's just so, he didn't do that, did he? So anyway, he's written a book called Make Physics Great Again. Okay, gross use of words in the context of current politics. And the subtitle is America Has Failed. Some kind of stupid bullshit. America destroyed physics. It's just such a pile of crap. And so clearly, okay, there's just no point in making this some sort of nationalistic crap. Physics is international. The world is one small little place now. This is just such crap to bring up, and especially from the German perspective, it's really a crappy, stupid thing to do. Assigning nationality to all these people. Einstein despised the whole idea of having a nationality, being property of a country, all of that crap. But anyway, I mean, it was a big part of his life. On the other hand, he was a big supporter of Israel, which is, but that's in the context of, legitimate reasoning for people to think they're on some sort of extermination list. But anyway, I don't want to even get into all that politics, but it's just the idea that somehow his chosen people, Einstein, Bohr, Dirac, and some other guy, somehow are the pillars of brilliant physics, and everybody else is some sort of idiot, and somehow all the other people were somehow Americans. So if you know anything about the history of quantum mechanics and even Einstein's theory, this had nothing to do with the Americans. I mean, everything that happened in the 1920s, 30s, even 40s, really had nothing to do with Americans doing physics. So it's, all of the horse shit invented was invented by some European, frankly. It's just such a pile of crap. Anyway, it's just this is just clickbait. Anyway, that's what the video just keeps saying. Clickbait, 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 bullshit. Who needs this crap in physics? Alright, anyway. So, really irritating. Really irritating. So, this video comments, yeah, on inertia, there's no such thing. Everything has to be pushed to go somewhere. You have to give it energy or it doesn't have energy. You don't need to call that inertia. Okay, it doesn't need a fucking idiotic word. Alright, then the Franklin Who stuff. The summary of the Franklin Who event is a pretty good video, I think, in pointing out what he actually did. And in this video, maybe I'll point out what he didn't do, which is actually show his experiment, frankly. And in the last video was just a little stuff on simulators and blah blah blah, how to simulate, a model of physics and the difficulties involved, blah 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 blah. Anyway, all right. So comments. So I'll read one Franklin Who comment, and I think, and just as a ground for having the conversation. Anyway, can you please explain to me in a simple manner what cart collision experiments have anything to do with kinetic energy? Well, they have a lot to do with it because you can collide things. I mean, it's like the Mythbusters experiment. They took something and crashed it into something else to see how much energy it has. It's a way of detecting how much energy something has. And the idea is that also you can do this conversion thing where you can take one kind of momentum, and through an elastic collision you can change it. So you can take mv, big M, little v, and convert it into big V, little m, by colliding things. And so that's why it's relevant, is because it makes little or no sense to me anyway, that you could create free energy by simply banging heavy things into light things or light things into heavy things. That doesn't make any sense to me. Okay. If you are measuring the M and the V and just multiplying them together, that is a momentum experiment. Duh. Like, we all know this stuff. So he really hasn't watched, like, maybe this is sort of like Piro. Somebody who doesn't really watch the content, just has some vague notion that some kind of video was made. And, and that's his business, okay? He thinks 5-minute physics videos make sense. He thinks, that videos should be as short as possible, blah, blah, blah. Okay, he has under time constraints. He has other things to do in his life, blah, blah. That's fine. Go on cruises, whatnot. But, I'm just going to counter-argue. That's just bullshit. Okay, if you're not going to pay attention to the arguments, of course you're not going to understand the arguments. Duh. You're not going to actually watch the videos and watch the explanations. Then yeah, you're not going to follow along. This is why all Gary's rants just flew over my head. So, I mean, this isn't very helpful. I mean, obviously it just, creates an instinct in me to just say your trivial mush doesn't appeal to me either. So what's the point of it? Okay. Obviously I'm not ranting in these videos. I'm pointing out how there's no history. Nobody has addressed the history. I keep pointing out there's no historical record for 1/2 mv squared, in sense of there's no science. Right? It's not a science history. It's a science of politics and bullshit. But there's no science. There's no evidence. There's no proving. There's no nothing. It's just a silly, stupid popularity contest kind of thing or something. And that should be reason enough for everybody to just say, well, fuck this. Why don't we get some real experiments? Anyway, because that isn't how you confirm deny a simple velocity dependent formula. Well, yes it is. I mean, levers are really good at proving the point, because basically you have an oscillating lever, okay, and the lever isn't going somewhere, so it's obviously there has to be the equal amount of energy on both sides, because it doesn't go anywhere. It doesn't wobble in some unusual way. It stays in the same space and oscillates. So it's a pretty good confirmation that the two sides of the oscillator must have the same energy in them, and you have completely different, okay, assignments of how much energy there are on the two sides, and the gun and the bullet kind of thing is a good analogy. So, I mean, I don't even understand how you can say this crap, frankly. I mean, but, it's it's completely made out of mass and velocity. They're squaring the velocity, so anytime you change mass and velocity ratios, you're going to be changing how much energy something has. So the whole idea of being able to do mass and velocity conversions breaks down. They're basically saying you can't do big M little v and then convert it to, big V little m. Can't be done. Momentum isn't conserved. They're making a pretty radical statement. And you're saying that doesn't prove? Well, I think it does. I mean, it's pretty decisive proof, frankly. You have to be able to demonstrate an exponential quadratic curve. Yeah, well, that's what the bullet and the gun do. That's what the lever does. The lever says, look, you have 2 joules on this side, and you're telling me I can have 2,000 joules on the other side. And it'll oscillate perfectly, and it'll balance when there's no motion. It'll balance perfectly with those weight ratios. Come on. Too silly. Alright, so that's probably enough. Alright. So Brozo's put in here, 5 million comments, just rehashing old history, just keeps doing it over and over, talking about experiments where I've already pointed out there's no theoretical possibility for what he's saying. He just ignores all these arguments, and so I hate to be redundant, but I'm just going to go over some of the stuff and over it because what's the point? I mean, he can't deal with the arguments. He won't deal with them. So and these monkeys, these creatures that call him Dr. Bro, which is just hilarious. They're not addressing any of this stuff. They don't know any physics, frankly. So that's the problem. There's really nobody in this conversation who knows what the fuck they're talking about. They really haven't watched the lectures. They really haven't done the work to know any physics. Alright. So that's a big problem. Alright, so the problem with Franklin's video, okay, I'd love if it was a great endorsement of what I'm saying, but there's a horrible suspicion lying in it that he, just made a mess of it. And so he's asserting that no one's done the experiment. Well, they sort of have done the experiment, they just didn't do it your way. So the idea is simply that you just have you have the same mass, and all you do is move one of them twice as fast. So it's sort of the Mythbusters thing in terms of the clay. Alright, so it's a pretty, if done well, it's a pretty decisive statement that you're basically showing, okay, that even though this has twice the velocity, it will not produce 4 times the damage. So when the car crashes at 100 miles an hour, okay, and 50 miles an hour, alright, it's just a 2-to-1 relationship. The one going twice as fast does not produce 4 times the damage. And then when they do it with clay, it doesn't produce 4 times the compression, just strictly 2. Now when they do it with braking distance, right, so they take a car, same mass, okay, change the speed, and do braking distance, it turns out that this does. Okay, the higher velocity one does travel further before it stops. So you have to apply more energy to stop it. Now that could be understood as simply being the problem of friction being less at higher velocity. Alright, but Franklin's experiment indicates something different. So this would be an example. The braking experiment is an example. Now they don't come up with the right number. They don't come up with any 4x. Okay, 4x doesn't happen in any real experiment. Now you get some vague references to experiments that have been done, and it ends up being some number between 2.5 and 3.2 or something. So not 1 to 4. Not close to that anyway. And so Franklin's saying that no, it's completely linear. That is, twice the velocity, twice the traveling distance. And it just doesn't seem to me that that's a reasonable expectation, because I would argue that the faster you're going, the less friction you have with the ground, less contact you have with the ground, because the ground is a round Earth. Puts part of the argument, and the faster you're going, the less impediments are a problem, because you essentially, anytime you are pushed up, lifted off the ground, you're going to incur less friction. So every bump becomes an excuse for something going faster not to be touching the ground anymore, which means it can't be giving away its energy to friction. There's a little bit reason to be suspicious of this perfect linearity between friction and velocity, because I would expect a faster vehicle to actually go further than twice the distance, because it is in fact spending half the voyage going much faster over the friction. So this would be the same as this, right? So his argument essentially is that as it rolls, so you push it and that's the last you give it energy, as it rolls, it reaches the halfway point. That is, it's going half the velocity. So if this is going 50, it goes 50 here. So in the part where it's going from 100 to 50, okay, somehow it gave away the same amount of energy to friction as in the 50 to 100. And that just doesn't seem very likely to me. So he doesn't show his experiment, doesn't show how he did it. And we've already seen how, it's pretty easy to, frame rate counting is it can be sloppy. And you have to make sure that the video does have constant frames, it doesn't do this. Little frame, big frame, little frame, big frame, because that's going to, depending on where you're counting, you could have, two things in the count, or go a little tiny bit more and you have three, so your counts can be pretty far off. Alright, so I don't know if I need to say more about it. I mean, he thinks this one piece of evidence, his experiment, is decisive and pure and all anybody needs. And I'd say, no, it's a little kind of far short of that. Now, it is good for one purpose, in the sense that all these experiments will show that it's not going to be 4 times the energy. And there's certainly reasons to understand why there could be a little bit of a difference, because friction isn't linear. Because friction isn't the same for an object going 100 miles an hour as it is for an object going 50 miles an hour, or an object going 25 miles an hour, or an object going 10 miles an hour. That they will, per unit of time or distance, give away less energy based on speed. Now, obviously, I'm saying when they're different masses, then you really distort the picture, because the heavier object will, in fact, give away its energy much quicker than the lighter object in terms of friction. Alright, that's probably enough on that. Now we'll do some of the Brozo arguments. Alright, should be back. Alright, so 90%, 85% of the Brozo videos, let's just say, are spring experiments, where he's making basically a statement about how springs work. Alright, so now there's a ton of evidence that springs collect momentum, because they've done these, Hooke's law kind of experiments where, you just put a weight on a spring, and yes, okay, springs work, okay, 10 pounds, 20 pounds, okay, it's always twice as much. Whatever the value is, it's a completely linear relationship for springs. The amount they compress is equal to the amount of the weight, the pressure you're applying to the spring. And Brozo, and they conserve momentum, obviously. This is just a diagram of momentum. And it's Brozo's contention that the spring conserves kinetic energy. So that if I have a spring compression of a certain amount, and I put a light object on it, or a heavy object, right, a 2-to-1 relationship, that that same spring, okay, won't do this. What it will do in terms of the momentum is that it'll give this only 1.4 the momentum. Okay, the velocity. It won't give it double the velocity. It'll only give it 0.4 more velocity than this. So this won't give it 1 velocity, 10 miles an hour. This will give it 14. Okay, so even though it's half the mass, it only gets 0.4 velocity. So that's his contention that this doesn't happen here. And it's just weight that moves stuff to create momentum. Let's understand, momentum mv, okay, was measured in foot-pounds, okay, foot-pounds. It's pounds, foot-pounds, it's weight. Momentum is a measure of weight, pressure. All right, so that's 85% of his video is saying he's proven, okay, that momentum isn't conserved. That is, I used a certain amount of momentum in to compress a spring. I could put the lighter object on and I won't get the same momentum back. I'll get far less. That's his contention. Okay. And you know, I'd say on its face, well, you got to really prove that. I mean, that's a pretty dramatic statement you're making. And so he's done a bunch of experiments, as I pointed out. You know, most of all of his experiments are either theoretical crap or they're making a statement that is defeating regular physics. It's not defeating me. It's not debunking me. It's debunking this, Hooke's law. It's debunking already well-established physical experiments and saying they're somehow not true. Everybody's been fooled and cheated by those experiments showing that because he's proven otherwise. All right. So let's go through some of that. Like I said, 85% of his experiments, they all have springs in them. Okay, so he has this way. So he's made the argument, okay, that, see, this was, you know, I mean, at the time I suggested this experiment, I didn't realize how circular it was and that you can't come up with any other result. This is sort of like the, you know, the initial experiment I suggested was shoot something with a spring, okay, and then collect the energy with a spring, okay. I mean, obviously it's kind of circular. How could you possibly come up with different results, right? This compression would have to end up with the same compression over here. You can't change that. Yeah, duh. You know, and so this other experiment is in the same vein. So maybe I'll erase this and go into these details. But I mean, they need to be addressed by one of these critics, okay? The critics have some obligation to actually pay attention to my actual arguments and actually engage in a conversation about the physics and the experiments that exist. There's no conversation here. It's just insane. Nobody is directly responding to anything anybody actually says except me. Alright, so at least 3 or 4 of Brozo's videos, maybe 5 anyway, just deal with this simple idea of you're going to shoot 2 different masses off of a cliff. And the idea is to give them the same energy, you know, same momentum. And so Brozo's using, again, springs. And he's arguing that, yes, he has accomplished the task of giving this one twice the velocity. So it's, you know, 1 mass, 2 velocities, 2 masses, 1 velocity. And the truth is that, you know, they have the same momentum. But the spring he's using, right, he's not producing that twice the velocity. And so obviously the landing results aren't going to be what he's claiming he's proving. So anyway, I mean, it's an experiment that you really can't screw up in any way. There's no way you could detect the energy of the objects doing the experiment because where they land is dictated by facts that you can't, you know, that are just unrefutable, undisputable, unchangeable. So the fact is, if you have twice the velocity in a lighter object, it has to go exactly twice as far. It just doesn't have any choice. That physics is nailed solid, and the heavier object will go the shorter distance because of the lower velocity. Because the rate that they fall in gravity Okay, the whole astronaut on the moon dropping the feather and the hammer, you can't undo that fact. They fall at exactly the same rate. And so all you're going to detect is that, yes, something going twice as fast will travel twice as far in the same amount of time in space. And in minimal air resistance, that's also true. Now, if you're rolling them on a surface, well, now you're changing the dynamic because the friction isn't fair. But everything in his experiment is fair. The aerodynamics is the same, and there's very little friction. So it's not going to have any effect on the experiment, and you have no choice. This has to happen. Okay, there's no possibility the lighter object goes, here or here. So he claims that he has accomplished this, that he's gotten the lighter object to go much further, demonstrating that it has more energy, when it's impossible for it to go further. It can't go any further. The velocity here dictates where it has to land here. There's no variable in here that can change that, because the rate they fall is fixed, and the rate they have to move based on their velocity is fixed. You can't change their velocity because there's no drag. There's no obstacle that you're collecting the energy and consuming the energy. You don't consume it till they hit the ground. So this is not a theoretically possible result. Clearly what had to happen is somehow you didn't give them the velocities you claim at launch. So you gave this one too little velocity, and then you can get the illusion that it's moved more than twice the distance. So somehow you failed to give this one half the velocity. You gave it less than half, and therefore that's why you got this experimental result where you got this result instead of this result. Is merely because you got this result wrong, because this didn't have half the velocity. All right. So all those experiments are absolute crap, because he has no hope of showing the energy here. You can't collect the energy in this air atmosphere. It doesn't create enough of a collector. It's not collecting. It's not taking the energy away. So you're not consuming any of the energy, so therefore you can't be measuring the energy by measuring how far it travels. And it's just... So all those videos are absolute garbage. It's not a theoretical possibility. It's impossible theoretically. All right. Now he has another video, okay, where he claims he's done frame rates, okay, and established, okay, that he has a 2 mass and a 1 mass, and he's established, okay, that this is going 1 velocity and this is going 2 velocity. And he's established it as an absolute fact with his frame rates, that this is the truth. So this just demonstrates how unreliable, okay, these experiments can be. That they can do an experiment and claim something, but again, you can know theoretically it can't be true. I mean, there's no hope. So anyway, so now he's got the simple task of merely crashing the objects into a spring and measuring how much they compress the spring. Now, quite obviously, I state, yes, 2 times 1, same as 1 times 2. They have the same momentum, they have the same energy, they compress the spring the same amount. So in this case, the same amount would have been the number 12. All right, for that theory to be correct. His theory is that, no, this is a kinetic energy thing. This 2 is squared, so that's 4. This one's only 2, so this one has... It should be 4 times the energy, but whatever. Somehow with 1s and 2s it's not working. Well, anyway, okay, that this one will have twice as much energy, so the number would be 16. So that's his prediction based on kinetic energy being real, and he's going to collect it with a spring. So he not only is saying these numbers are correct, but he's saying that springs collect kinetic energy, that they don't do the foot-pound thing, that they don't collect momentum, that they actually do show you kinetic energy. All right, that's his theory. Anyway, so he gets a result of 14, right? And what does he do? He claims victory. Now, I mean, obviously you could see that all he's done by doing the experiment is demonstrating. So he's saying that the one spring was 12, okay, and the other one was 14. 14. And now it should have been 16 if kinetic energy was true. The lighter one should push, okay, the spring more. And it didn't come out that way. See, the 16 would be 1.4 of 12. So that's why his prediction was 16. Alright, so all he's done is prove that he can't do an experiment. I mean, these were the only two possibilities. I'm of course arguing there was only one real possibility. This is the only possible answer, that these two things have the same foot-pounds of pressure. They have the same momentum. Springs measure momentum. They have to compress the spring the same amount if these values are correct. If he has accurately identified that this one is going, whatever, 100 miles an hour and this one's going 50. It's the other way around. This one's going 100 and this one's going 50. If he's actually got those numbers correct, there's only one possible outcome for the spring. And so all he's demonstrated with all those experiments is he can't do experiments very well, because he got an impossible answer. I mean, there's no theory to defend it. Kinetic energy can't defend it. Momentum can't defend it. It's, what the hell are you talking about? And yet he claims this shows us something. And all it shows us is you can't depend on his numbers. You can't depend on the way he's done an experiment. Alright, so we'll go into... Yeah, I might as well mention the clay thing too. But anyway, we'll see where I go. Clean it up and take a pause. Alright, so let's go over another glaring experiment that should give a rational person pause. Okay, so they're making an argument that something's true, and he does an experiment that just demonstrates, wow, it's not even close. It really can't be fit with the rest of the experiment. So either the other experiments are wrong, and this one's right, or this one's wrong for them to be right, right? So you have to explain that. So he has a pretty simple setup. Alright, lever with a bearing, alright, and a spring. Alright, so you pull the lever, compress the spring, and you push things, right? So he puts the two mass here, and the one mass one distance away, okay? So this one's twice as far from the fulcrum as that one. That means it's going to weigh twice as much. You know, if they were on if you were using the lever as a scale, you would get the same weight for the one mass here or the two mass here. You would use the same pressure here to compensate for both those things. They would essentially be, as I pointed out, impossible to tell the difference. If you pushed on this side of the lever, you couldn't tell whether I had a two mass here or a one mass here, because they weigh exactly the same. Alright, this one moves twice the distance, okay, that this one moves for the same pressure. Same movement. Alright, so this one gets twice the velocity, clearly, that this one gets. One velocity. Alright, so the two mass, one velocity, one mass, two velocity, and you have a pretty good guaranteed way to do it, right? So you make sure you compress the spring the same amount, that is, you pull this back exactly the same point, okay, and you have a stop here so it can't go any further. And he does this experiment. And he's doing it for some wacky purpose, like he wants to somehow prove that these things don't move exactly as I've described, and that the lever can't change its speed. So yes, if you put one on top of the other, if I did a video of just this one and then I did a video of just this one, every motion of the lever would be exactly the same for both videos. When this one's getting launched, this part of the lever moves twice the distance at twice the speed. And if when I had to do this experiment, this part of the lever moves exactly the same distance, it's exactly the same speed. You could just put them right on top of each other and it would look identical. Because nothing for the lever has changed. To shoot the one mass at twice the velocity, it has to move exactly the same as it moves for shooting the two mass at half the velocity. The movement of the lever, every place in space that the lever will go through this experiment, will be identical. Now he's claiming he's proven otherwise. And obviously this experiment pretty much proves, no, sorry, not close. Alright, so he does the experiment. This one bounces up and back, and this one bounces up and back. This one takes 19 frames, this one takes 11 frames. Well, I could draw that with thicker lines. Okay, 11. See, I just keep drawing it in the wrong place. 11. Okay, 19. All right. So pretty close to 10 and 20, which you would expect. And understand that his prediction, this should be 14 or, well, 15 or 16 at the most, 15.5 or something. So obviously it's not, it's showing something not what he would predict. It's not the result he would predict. Okay, and it's very, very close to the 2-to-1 relationship, pointing out that, yes, this is going twice as fast. Now, I could point out that you could know theoretically there's no option here. Okay, there really isn't. The two things have the same weight. They have to do this. Like I said, if I oscillate the lever, you know, I've stated this so many times. I mean, how can you think any other way? I mean, how do you people do this? How do you ruin logic and reason? You know, if I'm oscillating this, there has to be the same energy on both sides, because gravity is what's being used to store the energy. The energy stays in the system because the system is using gravity to keep the energy in the system as a battery. And so this one has to store just as much energy as this side stores, and by going up, storing the energy with the up motion, and then getting the energy back with the down motion. And both sides have to have the same energy on them. But the kinetic energy formula says this one's moving, okay, twice the velocity, and therefore has twice the energy. Now you can understand it can't have twice the energy. It's not possible. And his experiment basically demonstrates it's not possible. This is the truth, okay? And this, like I said, this could have easily been 20. This could have easily been 10. All right. So his own experiment says, no, your kinetic energy thing doesn't work. You didn't come close. And the logic here is kind of indestructible. You have to have the same energy on this side that you have on this side. It's it's impossible to theoretically explain how I can have twice as much energy on one side, that the half energy, okay, goes over here, somehow turns into the, you know, the full 2 energy, you know, twice the amount of energy, and somehow the twice the energy only makes half the energy over here, and then the half energy somehow makes twice as much energy over here. It's illogical. Really illogical. And yet I have to argue this for years and years and years. Alright, so that's and another example of why he can't be trusted as an experimentalist, because he's saying this proves and this proves and this. He keeps claiming it proves when his own experiments contradict his own experiments. They're not consistent results. They're completely inconsistent results. Alright, so let's go over some of the problems with springs. Okay, so I would argue that springs are pretty good at conserving energy. You can bounce something between springs, and you might lose 5%, maybe less, per interaction with the spring. So the spring's not perfect. It does get hot, the metal fatigues, this, that, the other thing. But generally speaking, they're pretty good at giving back what you put in, alright, in theory. But it's only a theory, okay, in the sense that, yes, you have to do it right. So, obviously a problem with a spring is that when you compress it, it can bend and do other things besides just compressing straight. So that's a real problem. So you're usually springs, when they're going to be used in some sort of device, they're in a container, alright, that doesn't allow them to twist and turn, because that's a way of avoiding the energy. You can sort of understand if the spring goes this way, yeah, it'll store some energy, but it's not nearly going to be the same energy that it would have compressed it. Okay, you're able to push the spring that way a lot easier than compress the actual coils of the spring. So you have to use some sort of mechanism to eliminate these problems. Now, one of the ways you can eliminate it is obviously stretching a spring is a lot harder to create some sort of problem. So stretching a spring is usually better than compressing a spring in terms of what kind of restraints you have to have the spring under. So if you put energy onto a spring That's why springs make good scales as stretching springs rather than compressing springs. It's a better scale. Now the thing to understand too is about when you're pushing and versus hitting something. So if you have a spring with a some sort of object at the end to hit something with, that's different, okay, than actually connecting to the spring and having the spring compress and then the spring expand, pushing the object. So you got to avoid hitting versus pushing. I could write the words hitting, pushing, but I think you can understand the difference. So if you hit an object with some energy, okay, and the object is free to move away, then that means that your hitter can be bouncing back and then hitting again and then bouncing back and hitting again, and it's using up energy to do that. And so you're not going to get the energy from the spring into the object because you're throwing things at it that are reflecting the energy rather than absorbing all the energy. So you need to push an object, okay, not hit it. Hitting it won't get the energy in. You get little arrows in, but you won't get all the energy in. You don't want the thing to leave the spring until it's gotten all of its energy out of the spring. Alright. And so, these are real things to consider. So Brozo has made a bunch of devices for doing this launching thing, and all of them are suspect for these different reasons. One, that the spring isn't contained, so it is just flopping on the end of something. So how you compress it will be dependent on just luck. One time it might compress a little bit, wound funny, narrow here, fat, and narrow, and it's not at all consistent in how it was compressed. Now the key thing that also goes with springs is the fact that the higher the pressure, the fact is that it's hard to release it instantaneously. You have to make some sort of device for letting the energy go. So you're holding it back, and then you're going to have a trap door or whatever you're going to have to let the energy go. And the clear thing that can be observed by anybody who's done any of these experiments is fingers are really bad at this. Okay, so you using your hand to your fingers to hold back the pressure, and then trying to release your finger quick enough doesn't really work, because no matter how you do it, it slides over the edge. Your finger doesn't move fast enough. You end up doing the hitting thing. You end up changing how the energy goes into the object. It goes in spurts. And so that doesn't work. And obviously some of his key experiments have this huge flaw in them, in that he's holding back two objects, okay, being propelled by a spring, all right, and with different hands, no less, and then pretending to let them go at the same time. And he's just pretending, because first, you can't do that with your own hands, getting it perfect, and how you let it go, that is how well you release your hands from the objects, let them go, whether you pull your hands up or whether you pull your hand out, different ways you can do it where you're going to get all the energy in, or you're going to consume a lot of it with just hitting your own hands. You're going to consume the pressure of the spring. The momentum stored in the spring is going to end up being absorbed by your fingers rather than absorbed by the object you're trying to propel. So those are big flaws in an experiment. You really do have to make a legitimate, equal way to release something that's going to absorb as little of the energy as possible. A quick release. And his substantial portion of his experiments lack that feature, let us say. Alright, so let's go back to where all this started. Basically was my rejection of some notion, okay, that a 10 mass thing, okay, going 5 velocity, alright, is somehow unequal to, okay, it does not equal, okay, a 5 mass thing going 10v. Alright. This has twice as much, 2x, the amount of energy. So if this has a 50, this has 100. Huge difference. And the consequence of that theory is that you could use the energy. I mean, I can't show you any device that would do that, but let's just say we used a spring. So we put a 5 going 10 velocity, and we plow it into a spring, and we take that spring compression, okay, we have a spring compression of a certain amount, and now we put 2, okay, 10 tons going, 10 units of mass, whoops, and the theory is, okay, that they're going to go 5. So I have twice as much, 4 times as much matter going half the speed, and they think that's going to work. That I can create 2 10-ton trains going 5 miles an hour with the energy of one 5-ton train going 10 miles an hour. That's their logic. And I obviously said that that's impossible. That's crazy. Okay, the 20 would have to go 2.5, not 5. Obviously, and it just doesn't make any sense. It makes no sense at all. That there's twice as much energy in this object versus this, the 10 going 5. They are in fact equal, okay? And physics says otherwise. And it says it out loud overtly. That's what 1/2 mv squared says, is that anytime I change this relationship between the mass to the velocity ratio, so Franklin doesn't think that's significant, but yes, anytime I change this ratio of mass to velocity and conserve the momentum, somehow I'm making free energy. I'm making more energy. So I can have the same momentum, yet more energy. But that's a reasonable concept, when momentum is basically defined by just mass moving. So where can I get this extra energy from if the movement isn't just as quantizable as the mass? Somehow the movement means more than the mass means. And the argument is it can't possibly mean more. But anyway, so the implications of this is there's experiments out there that show the creation of free momentum, free mv, because of this formula. So you just put, you just crash light things into heavy things and you create free energy. And that's also, I pointed out, not possible. And then the experiments I've demonstrated that some of them have glaring fudges, shenanigans, clay on the experiments, where it really shouldn't be there. And so they're basically telling you that you could have something, okay, that has a certain momentum, so the 10-ton train going 5, that I could put it into an experiment, okay, and I could create, well, I should do 5-ton train going 10, okay, maybe I'll erase. Alright, so you have 5-ton train going 10. I put it into an experiment, a box, and I end up with a 10-ton train going 5. Okay. Now the argument is okay, I have the same momentum, 5 times 10. Alright, but here I have 4 times the energy. And somehow, in doing the experiment, I made a bunch of stuff happen. That's where I lost all the energy. Here I only have 50 kinetic energy, and here I have 100 kinetic energy, you could say. So I have to somehow account for how I lost a whole bunch of kinetic energy. And so their argument is that I made a bunch of stuff move. And so I made stuff move without using any momentum, is the argument. How could you possibly imagine that something could make something move, but it doesn't have to use its own momentum? So it's just like saying the 16-pound ball going 8 miles an hour can hit a pin, make it fly off, and still keep the same momentum. That you could still somehow retain the same energy, the same 16-pound ball going 8 miles an hour, essentially. How can it make stuff happen and not lose its energy? I mean, it's a paradox. It doesn't make any sense. It can't be the truth. And yet I have to argue it over and over and over. Alright, so that's why it's relevant. It's because when you change masses, you're basically changing exponentially, potentially, or destroying energy. Either making energy or you're destroying energy. And there's lots of theories saying you can't do that. I mean, look, I could give the overt example of the gun, where obviously Newton says equal and opposite, yet you're saying the bullet has 2,000 joules, the gun has 2. How is that equal and opposite? How does that fit into anything Newton said or basically proved with substantial evidence and reasoning? It's clearly counter to that law. Alright, let's go over the clay stuff one more time. Alright, so in the 1735, somewhere in there, anyway, these experiments were done by a Dutch guy, I believe, but doesn't really matter. Alright, so you have a clump of clay, and what you're basically going to do is drop objects into the clay. Now, to get twice the velocity, they knew they had to go 4x the height. So this one is 4 times the height that this one is dropped from, to double the velocity. Alright, so same mass dropped, well no, half mass versus, no, yes, they use the same object, and they're just doing, essentially they're doing the same experiment that Franklin did. Alright, so you're just going to drop the objects from twice the velocity here and only 1 velocity here. Alright, and you're going to see how much energy the objects make by measuring it in clay. Alright, now obviously there can be some point made that clay isn't the perfect way to measure, because you're saying, well, what happens to clay? So I could argue that like a knife through butter, right? A cold knife doesn't go through the butter well at all. A hot knife just zooms right through, right? No pressure, no resistance, very little resistance. So you could argue that the more the object heats the clay, the further it's going to go into the clay. So you can make arguments about what clay does when you push an object into it, and that it isn't linear. That is, it isn't fair to both objects. That higher speed objects will penetrate clay easier than low speed objects. Now I could point out, if I did the same experiment with cornstarch, so if I change this to cornstarch, I would get completely inverse results. That is, the lighter object, the object going with the slower velocity would penetrate easier than the faster velocity. And the higher I make the velocity, the more likely it is to completely bounce off. So if the more velocity I give it, the less the substance yields. That is, it hardens with velocity. It gets stiffer with velocity. So it's clearly a reasonable thing to say maybe clay isn't a best way, penetration in clay. Now, the argument, I'd say the physics argument here, is that you're really just saying how much masses am I moving and how fast am I moving them. So the good thing about clay is when the thing hits, pieces of clay don't go flying off into the atmosphere at high velocity, consuming a lot of the energy. So at least we don't have that problem. And so you're really just talking about is how far do I have to move the piece of clay, right? So you could argue that if you are pushing down, you have to move the clay not only in this downward direction, but you actually have to turn the clay to get it out of the way, because this is creating back pressure. And the back pressure is going to mean it can't penetrate. So it has to do kind of a longer motion, you could argue. It has to move clay a longer distance than if it just pushes the clay sideways as it goes in. Now that's where the round object comes in the sense that the round object means it has a flat part here, okay, that forces the energy to go this way. And then on the sides, it's forcing the energy in all these other directions. And you're really just saying, well, how much does that direction have to do with pushing the clay straight this way, or having to push clay this way and then this way? So obviously this would be more energy than this would be. So the clay is not going to be leaving the object coming in. It's not going to be, the pins aren't going to be flying evenly. They're not going to all accept the same amount of energy. Some are going to have to be pushed with very little energy to get them out of the way. Some are going to have to be pushed with a lot of energy to get them out of the way. And so you could argue that the round surface creates a disproportion in the sense that obviously the further in it goes, the more it's pushing clay this way, and the less it's pushing clay this way. And the less it dents the clay, the more it's pushing down, and the less it's pushing sideways. So it can't take advantage of the short route that takes less energy. It has to use the long route that absorbs more energy. All right. So you're taking away more energy when you do this, okay, down and over, than when you do this, just over. More energy is taken from the object by those two motions. So that's, I'd say, the best of my arguments against clay. Now, I'm not saying there still isn't a bias. Obviously, the faster it hits the clay, the faster the little clay pieces are moving, the hotter they're getting, the more they're melting the clay, okay, and creating the knife and the butter problem. So there's definitely going to have an advantage. The higher the velocity, the easier it is to get through the clay, because the fact is because you're pushing objects fast in front of you, those objects are transferring the energy very efficiently. So the one piece of energy moves not just one piece of clay, but two pieces of clay, three pieces of clay, and they're all pieces of clay that would have been in your way. So you use one piece of energy to move four pieces of clay, where in this case you don't get to save any of that energy. The energy going sideways isn't reused. The energy going down is potentially reused in the sense that you're pushing the energy in the direction you're going, which means you're pushing the stuff in your way. The stuff you would hit, you're not going to hit because the stuff you hit previously hit it and moved it out of the way. So in some ways it's creating an advantage in the forward direction. All right. So I don't know if there's much else. So obviously, so when they did this experiment, yes, the object that fell further creates 4 times. Now, I would argue that whether it's 4 times or 3.8 or 3.2 or some other kind of number, depending on what clay you use, that it's not that precise. But yes, there's this huge difference between the higher velocity object and the lower velocity object that's consistent with this whole gravity thing and this idea that somehow this has 4 times the energy. But I'm arguing that that's only because the thing with twice the velocity, twice the velocity, is taking advantage of its shape change. And the fact that it's going to penetrate the clay deeper because it's going to be pushing more clay this way than pushing clay down. Where this one's pushing more clay down than that way because it has half the energy. And has to use, it's going to spend more time doing this flat surface doing work and less time the side surface. This one's going to have more time the side surface and less percentage of its total energy doing the down thing. So less of its energy is doing the down thing, more is doing the side thing, more is doing the down thing, less is doing the side thing. A perfectly valid argument, I think, to make about how the shape matters. Now, when the Mythbusters did the experiment, they just compressed a lump of clay. So they weren't penetrating the clay. They were just saying, we're going to put energy in. All right. And the clay molecules have to deal with that. So let's just say, for the sake of argument, it's an uncompressible liquid, the clay. And all the theory is that, well, since it can't compress, that it can't get smaller in volume, that the volume has to go somewhere. Okay, and that all you're going to do is basically push this side and expand these sides, and that's all that takes place. Is you're just going to move clay from a position here to a position out here, and that's where all the energy is going to go, is to just moving clay that way and that way. And it seems reasonable, and the results were perfectly consistent with momentum and perfectly consistent with actual car crashes that came out exactly the same way. 2-to-1 relationship. Twice the momentum, twice the compression. Not 4 times the compression. Alright. Do I need to say anything more about that? I don't think so. So yeah, maybe do the clay experiments differently, but again, it's just arguing that all of this is to try to capture energy And a joule wouldn't be, we wouldn't be calling the unit of energy a joule if this was easy. So, I mean, Joule had to, build a water tank and try to insulate it and do all this stuff and have had to make very high precision thermometers and, do all this crap to make a machine that could actually collect energy reliably. So it's not that simple. And, clearly there's lots of room to take advantages of things that aren't easily seen in terms of biases and mechanisms. You don't see that the heavy object has more friction with the ground. It's not obvious. You don't see necessarily, unless you do it on like a trampoline or something, you're not going to see the huge amount of more contact the heavier object has with the surface. So there's lots of hidden variables that have to be accounted for, and people will complain that somehow that's just a gimmick. That's just nitpicking. I think that's an evasion of responsibility. If you're going to make a claim, you have to substantiate it with credible physical experiments and evidence. And as stated, most of Stephen Bro's experiments come up with very uncredible results in the sense they contradict each other, subtly and overtly. Alright, so I guess that's the status of things. So I'm obviously contemplating experiments. I like the idea of using a simple pendulum because it does create reliable outcomes in terms of velocities, and a lever. And so just have a lever and just do the simple task of put in a pendulum, that has half the mass. You could do the same masses, I guess, right? We could do the same velocity argument. So I could use the same mass, and so we're going to hit the same location on the lever. And so I put a 2 mass here, and I have a 2 mass here. I could use a 1, but whatever. I'm just using 2 in the example. And so I just swing this in. Well, that really won't tell me anything because all I'm going to get back is what I put in. So I have to do the math, the mass conversion to see the kinetic energy thing. So yeah, so we have to put a 1 here. All right. So what we know is that 1, 2, twice the distance, at twice the velocity is going to have twice as much energy. And so the simple argument is I swing the 2 in, with half the velocity, that is from 1/4 the distance. Let it hit here, and if I get a 1/2 mass, going twice the velocity, come out of here, then I've made free energy. That's simple. If I can make a 10-ton train create a 5-ton train, that is, if I can make a 10-ton train going 5 miles an hour create a 10-ton train, a 5-ton train going 10 miles an hour, then I've made free energy. And obviously, free energy isn't possible. Because if it was, we'd have it. And anybody rational should be able to concede that point. But there's enough people been looking for perpetual motion and free energy that if it was that simple, you just swing pendulums into levers and you get instantly free energy, then it would have already been done and converted into a device we'd all have. We don't have the device because it can't happen. Because there is no free energy. What will happen is the object will leave with twice the velocity. The half mass will leave with twice the velocity, but it will not have any extra kinetic energy. It's just going to have the same momentum as the object that went in. And that's all it's going to have. That's all the energy it has, is its momentum. I guess I should just say one more time about the history. So everybody's ignoring in all these arguments the terrible history. It's an awful history. There is no evidence. There is no compelling arguments made with a pile of evidence. All there was a silly clay experiment that can be understood that the geometry was poorly chosen. That if you dropped objects that don't have a shape, that you're not going to get the same outcome. So it just fooled people, a gimmick. And that's all it is. So an entire formula is just based on a gimmick. And let's understand what the formula is. The formula is used to measure the weight of an electron. The formula is in all the nuclear physics. So all of it is corrupted by the fact that there's this pretend energy they've put in physics. And it's just pretend energy. It doesn't really exist as anything real. It's completely false, fake, phony. It's wrong. And the history demonstrates why you should understand it to be wrong. It's a contrivance. It's junk. And it directly leads to all simple devices creating free energy. And again, this argument was made over 300 years ago. People pointed out, well, if this kinetic energy thing is real, then levers are free energy devices. And we know they're not. So how can it be real? What's the counter argument? That's right, there isn't one. So somehow, again, I guess I should just illustrate that. Yeah, so I'll just illustrate what Stephen Bro was saying, which is, again, physically impossible. All right, so I guess Franklin Hu is kind of conceding that this argument's over his head. I just don't think it should be over too many people's heads, that this should be really easy to understand. Okay, so here's the lever again. 2 mass here. All right, now I'm going to drop the 2 mass a distance. So it started here, and I'm going to drop it. All right, now I have the 1 mass over here. Now, you know that if I put a 1 mass here and a 2 mass here, and I oscillate, it oscillates perfectly. So just understand that the motions are set. And so Stephen Bro's theory is, okay, and let's argue, okay, and the simple argument I'll make is that when this hits, it's going to start decelerating. So the 2 mass is going to start decelerating. Now, when there's a 2 mass here, right, if you imagine the 2 mass here, it decelerates at a certain rate, and this accelerates at a certain rate. When the 1 mass is out here, this acceleration and deceleration, that is, the motion here will be identical to as if there was a 2 mass here. So the deceleration here, understand, if the acceleration here would be identical, that means the deceleration here has to be identical to what it would be if it was just launching another 2 back up. So it'll be the same exact deceleration, the same rate of motion down will be exactly the same as if there was a 2 here or a 1 here. You can't change that. All right, so just understand that this can't tell the difference, and it won't be any difference in terms of how it decelerates. This has to be accelerating at obviously twice the velocity. This is going to move twice as much as this is going to move. This is going to, you know, I mean, it's that obvious. One's going to move this much, one's going to move this much. Okay, this is going to be half the movement of this. This is going to be twice the movement of that. All right, the velocity. So we know this has to be accelerating at twice the rate it would be accelerating here. This distance is 1/2 of this distance in terms of motion. So this one would be accelerating at a certain rate. This is going to accelerate exactly twice that rate. It's obviously going to end up with twice the velocity as it moves, because it will move twice the distance. There's no doubt about it. It has to move twice the distance. So it's moving with 2 velocity. And Stephen Bro's argument, that is when it's swinging, you know, this goes down and this swings up, and then it'll leave the lever somewhere up here. But let's just say we did it the other way around, and we have a stop here, and the lever went down this way, and now it's going back up this way. This object's going twice the speed that this one would go, and it's going twice the speed of this one coming down. You can't negotiate on that. That's non-negotiable, as Professor Hoon would say. So it's already going twice as fast. And Stephen Bro's argument is when the lever stops moving, somehow the velocity declines to 1.4. So it was going 2, and when it leaves the lever, somehow it goes to 1.4. And that's all it leaves with, is 1.4. So even though it has to go twice the velocity, and it is going twice the velocity, somehow it just knows, oh, that'll break the rules. I have to reduce substantially reduce. I have to go from 2 to 1.4. I have to lose a full third of my energy. Do you really think that's possible? That it leaves the lever at 1.4 even though it's already moving at twice the velocity? It's already moving to velocity, and it's just going to stop doing that for no reason and reduce its speed to 1.4. Now, I really shouldn't have to explain how that's garbage. And the simple truth is that when this goes in here, this will leave with twice the velocity, and there's no way this has twice the energy. You can't take 100 joules here, or 100 momentum, 100 foot-pounds, and make 200 foot-pounds on this side. Can't do it. Not possible. You can't do this fake energy nonsense. Alright. I just can't believe I can make these videos and it's just, no one will counter-argue any of this. No one will talk about any of these subjects. Nobody will do anything to in any way point out how anything in this video was a huge mistake, terribly wrong, erroneous, nonsense. Alright. Till the next time and such. I've done my job. I've been reasonable with the internet. I'm being reasonable, internet. I'm making reasonable arguments. Can you respond with a reasonable counter argument that's on the subjects? Alright. Enough of a video. Till the next time and such.